What was kind of interesting about this Chelyabinsk meteor is the fact that it really caught people off guard, especially scientists. In fact, quite literally, many scientists, that is meteor scientists who study these kinds of things, were actually looking the other way. There was another asteroid that was nearing the Earth, but wasn't really a danger, but they were keeping an eye on it, and so many of them had their telescopes and other instruments pointed towards this other asteroid right here when the Chelyabinsk meteor hit. So they really were not expecting it at all. It took everybody quite by surprise. So when the meteor actually hit, there were over 7,000 buildings damaged over the span of 6 cities. Now, again, a lot of that was glass, and especially large, large office buildings and stuff that had lots of glass right there. That becomes a major liability. And about 1,500 people were hurt as a result of flying glass and that kind of thing. But really, people did not know what was happening. So people thought it was the end of the world. And of course, if you think that's the case, what are you going to do? You're going to call everybody you know and say goodbye or whatever. So of course, cell phone networks were absolutely flooded, much like when 9/11 took place. Same thing. Any major event, you're always going to have cell phone networks that are flooded. People calling to either communicate legitimately or people calling just to talk about whatever. People want to talk about it, and so you're going to have those kinds of systems flooded. So one possible way to mitigate these kinds of things would be to make sure that we have backup networks such that the agencies that really need to communicate, like government authorities and rescue agencies, that kind of thing, can actually do that. The other thing was that this took place in a fairly cold time of year, and if you're in central Russia, it's very harsh, and so all these broken windows in homes, man, you've got a lot of people now that have homes that are no longer heated, or if they are heated, it goes literally right out the window, and so the weather played a big part in them having to really respond to this, especially all the broken windows, because people otherwise are going to freeze to death in the Russian in the bitter Russian winter. So we're going to keep all this in mind as we look at naturally occurring impacts and things that cause extinctions. We're also going to look at a few man-made things as well and see if we can compare them and find some similarities and some differences. But this is a kind of our case study, so we're going to refer to this. Incidentally, we're also going to look at a couple, like I said before, a couple of different videos of this taking place, and so you can ask yourself, well, what would you think this is if you saw this, burning in the atmosphere above your house? So we're going to start section 1 by looking at the scientific explanation for the origin of Earth and our place in space. Of course, we know we're in the solar system, and the solar system is part of our local star neighborhood, which is part of a bigger neighborhood called our galaxy, the Milky Way. But through the lens of scientists, we're going to look at Earth's formation and the various different time periods that many scientists believe that the Earth went through. I don't mean for this to be a controversial thing, because people have various different beliefs on the origin of the Earth. I have my own as well, but we need to keep in mind that this is a science class, and this is one viewpoint, and it has become agreed upon by scientists because of scientific exploration. That's all I'm really going to say about that. This is simply one explanation for the origin of the Earth. So, of course, you've heard of the Big Bang. If for no other reason than, of course, the TV show, The Big Bang Theory, which, aside from being a bunch of geeky science guys, probably doesn't have much to do with the actual theory of the Big Bang. But the theory is this explosion produced all kinds of atomic particles that became atoms, and then atoms that joined together. Now remember, anything that has mass has gravity, and so all this various mass, even if it's just little particles, due to gravity, is going to start to contract together. So that's what stars are believed to be. That is, all these various different atoms and gases that contracted together because of pulling together because of gravity. And the more it pulls together, the more gravity there is, and so the more that it pulls stuff to it. And so this giant cloud, as it were, of particles is really going to separate into kind of clumps of denser and denser particles that is believed to be the origin of stars. For reasons that we won't talk about, large stars actually have less of a lifetime. There is a star in the constellation of Orion called Betelgeuse, believe it or not. It's not spelled like beetle and juice, it's spelled differently, but this is an enormous star, probably millions of times the size of our sun. But we believe it's likely to die very soon because it's very, very large. Other stars like our sun, and our sun is kind of average to smallish in size, is believed to have much longer lifespan because of the way fuel is burned up in stars. And again, this is nuclear fuel. This is a process called nuclear fusion that takes place in stars, and we're going to see a few fusion reactions in man-made atomic bombs in class. So we've replicated what takes place in stars, but regardless, in order to create this energy, mass has to be consumed, and so it's actually consumed much slower over a much longer period of time in smaller stars like our sun. This one star, in fact, I'll write the name out right here, Betel, B-E-T-E-L, let's write it in red right here, because it actually is kind of a reddish star, B-E-T-E-L-G-E-U-S-E. It's in the constellation of Orion. Is very likely to become a supernova when it dies. That is, a star collapses in on itself. We have these two forces that are really keeping a star the size that it is. First of all, we'll just pretend this is Betelgeuse right here. We have the explosive force of nuclear fusion, F-U-S-I-O-N. It's different from what takes place over the hill at Limerick Nuclear Power Plant. That's called fission, F-I-S-S-I-O-N. That's splitting apart atoms. So F-I-S-S-I-O-N. So you've got a big atom right here with lots of particles in it, and it's split into smaller ones, okay, and releasing energy as well. With nuclear fusion, you have the opposite taking place. You've got smallish atoms, all right, and they are joined together to create, a larger atom and even more energy, all right? So that's what's taking place inside things like our star and in thermonuclear bombs, like hydrogen bombs and that kind of thing. This is Limerick Nuclear Power Plant. We can control that. We can not control this. By the way, if you figure out how to control nuclear fusion so that it's actually safe, you'll become a billionaire because it would be kind of basically an unlimited source of energy for us. But anyway, nuclear fusion is wanting to blow stars up. All right. Well, what prevents stars from actually blowing up but the force of gravity? Gravity wants to crush stars and pull inwards. All right. So you have these two forces that are balancing each other out right here. Well, when the fuel finally runs out in a star like Betelgeuse or something like that, all of a sudden you no longer have this outward explosion of fusion, and so the only thing that takes over is gravity. And gravity makes the star collapse, and then what it does is it kind of rebounds back into a giant explosion called a supernova. What that does is scatters all kinds of dust and atoms and particles into a giant cloud, and it becomes kind of the source for all kinds of what you might call cosmic dust that is able to kind of float around our universe. Some of it actually congeals to form other stars. Other parts of it form other objects. And there's the bell. Other objects, we believe, that could form solar systems. Planets, moons, comets, that kind of thing.